Welcome back. In this video, I will discuss how to compute correlation between similarity matrix and ideal similarity matrix with a simple solved example. In this case, we have been given 4 points P1, P2, P3 and P4. P1 and P2 belongs to cluster number 1. P3 and P4 belongs to cluster number 2 here. Also, similarity matrix is given to us. Given these two matrices, we need to find the correlation between similarity matrix as well as ideal similarity matrix. Now the question comes in front of us, what is ideal similarity matrix? Ideal similarity matrix contains for ijth entry 1 if two objects belongs to the same cluster, 0 if two objects belongs to different clusters. For example, let us say that point 8 here. Point 8 is between P1 and P2. P1 and P2 belongs to the same cluster, so this point 8 is replaced with 1 in ideal similarity matrix. Consider one more example. 0.65. This 0.65 is between P1 and P3. P1 and P3 belongs to different clusters here. P1 belongs to cluster number 1. P3 belongs to cluster number 2. Hence, this 0.65 is replaced with 0 in ideal similarity matrix. Now we need to find the correlation between similarity matrix and ideal similarity matrix. So first we will write the vector for similarity matrix. While writing a vector for similarity matrix, we will consider only off diagonal values. That is, these are the only values we will consider in this case. The same values are repeated in this part of the matrix, so we consider only these. There are 6 values are there, so we can say that the vector x contains 0.8, 0.65, 0.55, 0.7, 0.6 and 0.3 over here. And the associated ideal similarity matrix y contains, or ideal similarity vector y contains, for the first value, that is 0.8, if you look at here, 0.8 is between P1 and P2. P1 and P2 belongs to the same cluster, so it is replaced with 1 here. Now coming back to the second one, as I said earlier, 0.65 is between P1 and P3. Both of them belongs to different cluster, hence it has been replaced with 0. The same has been repeated for remaining elements over here. Now once you know these two vectors, we can easily calculate the correlation between these two vectors here. Again, if you want to calculate the correlation between these two vectors, we need to calculate the first one known as the standard deviation and one more thing called as covariance over here. First, we will try to calculate the standard deviation. The equation for standard deviation is square root of summation of xi minus mu bracket square divided by n minus 1, where mu is the mean in this case. So again, if you want to calculate standard deviation, we need to know the mean of that particular vector. So first we will calculate the mean with respect to x. So add all these particular values divided by 6, that is nothing but 0.6 over here. This 6 is nothing but the number of elements over here. Now once you know this particular mean with respect to x, the standard deviation with respect to x is equivalent to square root of xi minus mu bracket square. So xi is what? 0.8 here minus 0.6 bracket square plus second one is 0.65 minus 0.6 bracket square and so on, divided by n minus 1. So n is how much? 6 here, so 6 minus 1 in this case. So once you solve this equation, you will get standard deviation with respect to x is equivalent to 0.1703 here. Similarly, we need to calculate the standard deviation with respect to y here. For that reason, first we need to calculate the mean with respect to y, add all these elements divided by 6, that is nothing but the number of elements, which is equivalent to 0.33. Standard deviation with respect to y is equivalent to square root of this one xi. Xi is what in this case? 1 minus 0.33 bracket square. Second one is 0 minus 0.33 bracket square and so on with respect to all elements here. Divided by 6 minus 1 because n is the number of elements in this case, that is 6. So if you solve this equation, you will get 0.5164 as a standard deviation with respect to y here. Now we have calculated standard deviation with respect to x and y. We need to calculate the covariance between x and y. Covariance between x and y is always equivalent to summation of xi minus mu x multiplied by yi minus mu y divided by n minus 1 in this case. Again, n is the number of elements that is known to us, 6 here. We need to solve this particular numerator. The numerator contains xi minus mu x. Xi is 0.8 minus mu x, that is 0.6. multiplied by yi. Yi is what? 1. 1 minus 0.33 in this case. Second time it will become 0.65 minus 0.6 and then 0 minus 0.33, so on for all these particular elements. The same thing I have written it here, divided by 6 minus 1, and once you solve this equation, you will get the covariance between x and y is equivalent to minus zero point 0.2 here. Once you get the covariance, you can calculate the correlation. The correlation between x and y is always equivalent to covariance between x and y divided by standard deviation with respect to x multiplied by standard deviation with respect to y here. Covariance we have already calculated. We have calculated the standard deviation with respect to x. Standard deviation with respect to y is also calculated. Once you put all those particular values and if you solve the equation, you will get the correlation between x and y is equivalent to minus 0.227 in this case. So in this video, I have discussed what is similarity matrix, what is ideal similarity matrix, and how to find ideal similarity matrix given a similarity matrix over here. Finally, we have calculated the correlation between similarity matrix as well as ideal similarity matrix in this case. I hope the concept is clear. If you like the video, do like and share with your friends. Press the subscribe button for more videos. Press the bell icon for regular updates. Thank you for watching.